Welcome back to day 2 of macro writing workshop. On day 1, I have introduced the basics of ImageJ macro language. First, we have went through on how to record our image analysis workflow and also how to run batch using macro recorder, batch plugin, and script editor. Then we went through what kind of elements are there and how they are used with few examples. So from the activity 1, now we understand the usefulness of variable in reproducible coding. And for the activity 2, the script can be written this way, where you can assign each number to a variable. Then you can calculate sum and mean using variables. And you can also print out in a format as you like. The activity 3 was to introduce an intentional error at the end of your previous script to open debug window, as in this example. In this way, we can inspect the name and the value of variable all together. Activity 4 was to practice conditional statements and using the functions that applies to the image windows. And activity 5 was to practice on how to use the Boolean operator. In this example script, it should print out the second sentence, which is all rocks. Activity 6 was practicing the conditional statements along with Boolean operator. And this example was to show that we can set up multiple conditions for multiple groups. And the last activity was testing these 4 lines of code, which opens the image from the folder specified by us. This was using the for loop and array, and this will be the starting point for today, where we are going to add image processing step inside this for loop. So after the first image is opened, we will process the opened image and save the result and close all the images for the next turn. So let's start day 2, where we will go through the first example of image analysis workflows. This example will show how to perform cell counting in batch. As I mentioned, we will start from the file opening loop we have created yesterday and also cover the file saving options and other tips useful for batch process. In terms of the image processing step, we will use the same cell counting workflow we did during the day 1. So we will set the threshold, make into a binary image, run Watershed, and then set the measurements before running analyze particle. But from there, we will make a slight variation that we will set the outputs of analyze particle as bare outline. This is because we can combine this outline image and the original image together to make a proof image. You may think that the measurements is already there, so wondering why we need this step. Making proof image is very important thing to consider when we are planning batch process. When processing many images in batch, we never know if our workflow that is set based on only few images are going to be good enough. So making a proof image where we can compare the original data and our segmentation result is important in checking if my workflow is reliable. Although it's not going to be covered here, you can make your proof image in many different styles, such as using overlays or placing the original and the result next to each other rather than overlapping. You can do this by using Stack Combine tool. So on this proof image, we will save it as JPEG format in the output folder, which is different to the input folder. And then we can finish this workflow by tidying up our workspace by closing all opened image. And lastly, all of this workflow will be placed inside for loop where we have set to open images. And we will add this within our for loop after the open command. So now we know the entire workflow. Let's start writing this step by step. After watching this video, you can reply from our YouTube channel and pause to work on your own pace. Also, the instruction PDF is included in the workshop material which you have downloaded. So the first step is to open the first image using our file opening template. Let's start with opening the activity7.ijm file which we have saved in day 1. I will adjust the font size so you can read better. And I will add comments for this part. Next, we would like to open the first image. We can open the image using this code instead of dragging and dropping manually. But also when we run this script, we will not be running the entire loop, but just running the first before the for loop finishes. We can do this by selecting the lines until up to the open command. Then go to the run on the menu and use the run selected code. The shortcut for this run selected code is Ctrl-Shift-R, and this is one of the most used shortcuts as you are writing script. When running this selection, the file selection dialog will open from the get directory function we have used here. And when we select the image folder, this getFileList function will assign the list of files to our array named as list. And from this for loop, the first image from the list will be opened. Before we duplicate the image, there is one thing we can also do, which is getting the name of the image and store into a new variable. We will use this function called file.name without extension, and as the name of this function is already explained, this function will grab the name of the file we have opened without the extension part, which is .tif in this case. So the string that will be assigned to the name only will be nuclei-1 instead of nuclei-1.tif. Then later, when we make the name of our output image, we can simply add .jpg at the end of this name. We can still use the full file name, which we can get either from getTitle function or even using the list box bracket I with .jpg, but then the full file name will be nuclei-1.tif.jpg. This file will still be recognized as JPEG image, but this is not neat and it's not looking good. So this part is rather for the aesthetic of output name than function. This function cannot be recorded, so we have to type in our editor and we will assign the return value to a variable as name only. As you can see, it is also good coding practice to name the variable that matches to its content. So rather than naming as A or B, I can figure out what this variable is much easier. The next step is to make duplicate image so we can use it for our proof image later. We are making this duplicate because the original image will be modified into a binary mask when we apply the threshold later on. This step can be recorded, so let's open the macro recorder through plugins, macros, record, or we can simply right-click on the image and select the record from the menu. So place a recorder on the side and right-click on the image again and select the duplicate from the menu. On the pop-up menu, we will name the duplicated image as dupe and click OK. The duplicated commands recorded can be copied and pasted, and I will also add comments for this part. Just a tip for this process, there is a reason why I have used a static name when duplicating an image. If we don't name, ImageJ will automatically rename the duplicated image based on the original image title. And depending on our image name, it will make an incremented name if it ends up with dash and number. So the name of duplicated image from the nuclei-1.tif will be nuclei-2.tif. But if the title of the original image ends up with any character, it will add -1. So rather than worrying about what our duplicated image name will be, we can simply assign a value, and this will also make it easier to identify what this image was duplicated for. So now we will go back to the main image process stream. I will select the original image window and apply threshold via image adjust threshold. Then I will use the default automatic threshold method and use the dark background mode and click apply to make our image as a binary mask. On the binary image, I will run Watershed via process binary Watershed. We can cut and paste our recordings. While writing the code in ImageJ macro, indentation is not compulsory, but it is much easier to read the code if the code inside the loop or if statements is arranged with indentation. So we can select these lines and press tab to indent. And then we will add a comment for this part. I will include an analyze particle here as well. And these two lines are not necessary, so we can delete. For the select window command, we can replace the image title with a variable. And we can use list box bracket I, just like as we used in opening file command. Then I will set up measurement and run particle analysis. I'm going to go to Analyze, Set Measurement. I will select the measurements for area and mean gray value. And because I'm measuring this mean gray value, which is intensity, I'm going to redirect my measuring settings to the dupe image where the original intensity information is still kept. This wasn't necessary on day 2 workflow as we were just measuring the area, and area can be measured from the binary mask image. But the intensity of binary image will be 255 as this is the maximum white value for 8-bit image. So in this workflow, the measurements needs to be redirected. Now I can go to Analyze Particle and set the size filter from 100 to infinity. Circularity filter 0.5 to 1. And set the show option as bare outlines. And select the option for display result, summarize, exclude on edges. We can then cut and paste both options to our script. Next part is making a proof image. First, we will rename this drawing of nuclei-1.tif as outline to make it simpler. Then I will invert the image via Edit Invert to make the outline as white color. Then I'm going to add this white outline onto the duplicated image I have made before. I can do this by going to the Process, Image Calculator, and select the first image as dupe, and select the operation as add, and select the second image as outline. I will then untick Create New Window option, and in this way, the result image will be overwritten to the first image. We can cut and paste the recordings, and set the indentation correctly. We can add comments, and remove these two lines, which is not necessary. And also these two lines, which was recorded while I was rearranging the windows and not necessary for the image processing. Now we have the proof image, so we will save it and clear out the workspace to be ready for the next image. First, we will save the proof image. Let's start with comment. As we have many images opened, and if unspecified, any commands will be applied to the active image window. After the image calculator, just to make sure that we are saving the correct image, I'm going to specify the image window I want to process using select window command. And then the command for saving files with specified format is save as. Here we can set many different formats, and we also have to specify the path where the file is going to be saved. For the format, we will use JPEG for JPEG image. And for the path, we will set it similar way to input path by adding out dir and the file name using the plus operator. For the out name, we can use the name only variable as we have said before. And we can add additional strings such as underscore result. For the out dir, we can also use the get directory function as we have used for in dir. And we can sign it after we have set the in dir at the start of the script. But we can change the description as select the destination folder. And let's modify the comments as we have also added output directory line here. So the out dir variable is now set, and as a last step, we can clear up the workspace and memory. At the moment, we have summary table and the result table, which we would like to keep for the rest of the process, but these three images needs to be closed before the next iteration. To close every image, we can go to the files and use close all menu. It will be recorded here. One other thing that we should be careful is that ImageJ doesn't empty memory even if we have closed all the images. You can check the current memory usage via plugins, utilities, and monitor memory. To clear up the memory, we have to go to another utility menus, which is located at the bottom of the list, and select Collect Garbage menu. As you can see that the memory is now cleared and the command is recorded. So we can add this to our script. For these two commands, we can also easily grab from the auto completion of this script editor by typing close, and you can find the close all function here. Same for the collect garbage command, that it is much quicker to get it directly from the auto completion list. So we are done for the first image, and the only thing to remember is to close the for loop at the end using this curly bracket. Then we can save this file as 1_cell_counting_batch.ijm. Now we have this complete code, so let's test if this works. When running this code, we can select the image source folder and then the output destination folder. Then you can see that each images are opened and processed. We can also check if the output files have been saved as the file name we set. For running batch, we can also add another function which is called setBatchMode. And this can be placed before opening image and outside the for loop. When we set the batch mode as true and run the script, all images are hidden and the macros can run up to 20 times faster. I have placed the final code here for your reference. And this is the end of day 2 for macro writing workshop. There is only one activity for you to do before tomorrow, which is completing this example by yourself. Thank you for your attention.